Unit 2, Video 1, talks about Learning Target 1, and this entire learning target is all about linear relationships. And really this whole unit is about linear relationships. Linear relationships are something that you've heard of before and that you know what these are before, or you've worked with them a little bit before. But the goal of this unit is sort of to really solidify and deepen your understanding of linear relationships, because it's a big concept for this year in algebra. So the first thing that I would like you to do is just talk about what you know about a linear relationship already. Maybe it's something you remember from last year. Maybe it's just something you know the definition of linear, but just on this your definition part, go ahead and pause the video and then just write down anything that you know, just sort of your own brainstorm about what a linear relationship is. Okay, so you've had some time to sort of write down your own thoughts. These by no means have to perfectly match the definitions that we're about to write down, but you should see some sort of connections between them now that you've had a chance to kind of get your own thoughts down on your note guide. Just a real quick note, your book will use the term recursive routine instead of linear relationship. That's not something that we will really talk about much in class. We will not really use the term recursive routine like ever. But if you see it in your book, that's basically what it means. And kind of what they're saying a recursive routine is they will have a start and then a next. And that's sort of how they'll talk about it. So they might say start with 5, and your next term is add 3. And so that's sort of the terminology that they will use for a recursive routine. It ends up being a linear relationship, but that's just sort of how they write it as a heads up for when we do the focus problems later. For now, though, the definition that we would like you to have for a linear relationship is that it can be represented with a straight line graph, and that a linear relationship is a relationship where, I typed that twice. Good job, graph. A relationship where a variable changes at a constant rate as the other changes. So there's this sort of tug and pull relationship that when one of the variables changes, the other one that's dependent on that changes as well. So you might be talking about height versus weight. If someone's height increases, typically their weight increases as well. So there's sort of a relationship there. The next one is rate of change. And there's a whole bunch of different words for rate of change. They all mean the same thing, but there are just tons of different ways to talk about it, to calculate it, to see it in an equation. So here are all of them probably that we will use. The rate of change is also the slope of a line. It's also the constant rate in a y equals mx plus b type equation. M right here is the slope. You've probably heard rise over run before. So we can see or calculate the slope as rise over run. The coefficient of x, and again that just basically comes from right here, that m is the coefficient of x right here. And then the last one, and you may or may not have heard of this one, and actually there's a typo on here. Again, that's my fault. But another way to talk about rate of change is the change in y over the change in x. And that's sort of the same thing as saying rise over run, because the change in y is really the rise, and the change in x is really the run. So these two are sort of the same thing. Change in y over change in x. If we think about rate of change in terms of a real-world problem, say maybe you get paid or I'll think of an example. Actually, this is actually true from when I was a kid. My parents used to pay me to pick up sticks, which is kind of weird thinking about it, but they would give me like, I don't know, like $2 or something, and then they would give me like a nickel for every stick that I picked up, which like I'm pretty sure was like child labor laws or something involved there somehow. But basically what would happen is like I would get $2 no matter what, but then I would get an additional 5 cents for every stick that I picked up. So this 5 cents is like the rate of change. Depending on how many sticks I picked up, it would change the amount of money that I got. And so there's sort of an example for you of me being used for my stupid not knowing what money is and picking up sticks for 5 cents a stick. Rip off. But anyway, so that's sort of rate of change. In this case, it's 5 cents. The starting value is also known as the starting point, or what you initially have. So in this example, if I don't pick up anything, I get $2, which I wasn't smart enough at the time to just realize that. Wish I was. But that's what I initially have. Like if I don't do anything, I just initially get $2. It's also the y value when x is 0. So if we think about it in terms of a table, xy table, when x is 0, this right here is our y-intercept. And in the y equals mx plus b equation, b right here is the starting value. So this b starting value comes from right there in the y equals mx plus b equation. If we look at where the line crosses the y-axis, if this is the graph of our line, it crosses the y-axis right there. And so this point right here is the y-intercept. You know, in this case, if we look back at our table, this is where x equals 0. If I'm going to write the coordinates of this point, it's going to be 0, comma, whatever the y-intercept is. So when x is 0, whatever that value of y is, that is the y-intercept. And it's wherever this line crosses the y-axis. Okay, so looking at an example that doesn't have to do with my parents taking advantage of me, you walk into an elevator in the basement of a building, and when you initially walk onto the elevator, the control displays 0. So you're on the 0 floor. As you go up, the numbers increase by 1, so you're getting one floor higher and another floor higher and another floor higher, and the elevator takes you up 13 feet each time you go up a floor. So this graph down here sort of shows your movement. You start here at floor 0, and it looks like you're actually underground, so floor 0 must, I don't know, be in the basement. Maybe it's a hotel or something, and you walk a few steps down to get to the elevator or something, I don't know. But you actually start underground here, and then you go up. Each floor that you go up, as we see it increasing on the x-axis, each floor that you go up, you rise 13 feet. Okay, so the rate of change for this situation is rise 13 feet over run 1 foot. In other words, I go 13 feet up every time, and I guess actually maybe that should be 1 floor. 13 feet per 1 floor. So the rate of change for this is really 13 over 1 is just 13. So each floor that you go up, you rise 13 feet. So that's the rate of change for the situation. The real world meaning of that is sort of similar, that each time you go up a floor, you rise 13 feet higher. Okay. So then how is this rate of change represented in the graph? If we look at this graph, we can see that we kind of start here at the 0th floor, and it looks like we're kind of starting underground, but we know that the rate of change is 13, so that means that I rise 13 feet every time I go up one floor. I rise 13 more feet every time I go up the next floor. Rise 13 feet if I go up one more floor, and the same, you go up another floor, you rise 13 more feet. Okay, and so that's why if I get rid of all those little stair steps, it makes a nice straight line here. And if you go back to our definition of linear, that's one of the things that we said about linear, was that it's a straight line relationship. Okay. Your before class, if you look at the graph down here, it shows a student's distance from class. So they start up here at this distance away, and as time goes on, as the seconds tick by, she gets closer and closer to class. Her distance to class decreases. Okay, so your job for the before class is to, like I did in the last example, look at what is the rate of change for this situation, and you may have to estimate what is the real world meaning of the rate of change, and then what's the starting value, and what does this mean in terms of this situation with the student and their distance from class.